Hello, this is a tutorial on how to create a simply supported beam. This time we're looking at bending moment diagrams. So if you haven't seen this beam before, I've done a further video on how to solve a simply supported beam with 3 loads and 2 reaction forces, so you can check that one out. Once you've solved it, you need to then go away and create your shear force diagrams. That's this diagram we're now showing on screen. You need to have this diagram to be able to create a bending moment diagram also. So if you haven't seen that, please check out the other video on shear force. So bending moment diagram, this is where we need to work out on our beam, which we know where our shear point is. We work out our shear point is about 4 meters, so we actually have a positive zone which is to the left, which is counteracted by RA, and negative zone which is on the right, which is counteracted by RB. What we need to do is work out, is our beam in the positive bending, so it's going to be a happy beam, so it's going to have a little happy face, or is it going to have a little unhappy face? Okay, these are known as positive, which is a sag, negative, which is a hog. Now to work out these beams again is very straightforward. So you're going to need to build yourself a graph, try and roughly keep the same distance would be good. Didn't really know what happened there. Let's go with that one, let's do another one. I think I roughly did it. Let me see that so I can see what's going on. Like so, but just generally trying to line up then our values above a little easier. So 0, this line is 2, this line is 4, this line here is 6. Obviously this isn't very accurate, but you know, these must is 7. Okay, so we know this one is obviously our shear. Okay, this is going to be our bending. And again, we have our force on the x-axis, distance on our y. Which obviously is completely the wrong way around. By x along the corridor, up the stairs. So, how do we work out our bending moment? Well, again, we've used this term before. Let x equal something. So, we will start with 0. Now, at 0, we're going to have a bending moment of absolutely nothing because nothing's happening as of yet. So we're going to have a force coming up, but nothing's happening because it's only a reaction to our next force. What now we're going to do is close off and form 4 rectangles. So rectangle number 1, number 2, number 3, and number 4. And this is going to symbolise our 4 points on our diagram. So we know that the area of a rectangle is base times height. Okay, so what we're going to do is obviously base 2 meters, height 155. So area 1 with 155 times 2. That's going to be my area, which is going to give me my bending moment force. So it's going to be 310. So my first point here, which we're just going to draw as here, which would be 310 on our moment diagram. Next one, we have then area 2, which also has a distance from 2 to 4, which is also 2. And we have a load of 30. So obviously that's going to give me 60 there. So what we're going to do is then draw on our line. Now what you have to do is once you have one area, you have to add the two together. So obviously 310 and 60 will give me 370. Now this is where we come up with our positive shear into our negative. So area 3, we go from 4 to 6, which is still going to be times 2. And this time we're coming down minus 70. So minus 70 times 2, minus 140. Okay, and again, add 2 and 3 together, so at 0.6, we're coming down to 230. At 0.4, we have a distance of 1, we have a distance of negative 230, so that equals negative 230, and you've guessed 3 into 4 brings us straight into 0. If you try and run a line of best fit, hopefully you draw better than me. Run it up, down, down, and down. That's our bend and moment diagram, which then shows our bend. Now we're showing currently moments positive anti-clockwise, is why it's given us a positive region or zone. If you did moments as clockwise, which is a negative, obviously it would drop it into a sag or a unnegative, so basically put everything down. Because our loading, we know our beam, because it's in the positive, okay, it's going to be a sag because it's given us positive max bending of 370. Won't be kilonewton meters because it's actually kilo. Of max bending, so that's going to be our maximum bending moment, 370, and that sits at 4 meters. That's how using a shear force diagram you can further on make a bending moment diagram. What's interesting as well, for a comparison, if you have software programs like MD Solids or SkySkiv or Beam Guru, you can actually go away and check that you've got all your answers correct. And obviously we've done ours like this way around, so positive, which is anti-clockwise, so that shows our positive shear. We're showing all forces, positive is coming downwards. Okay, you can also change that on MD Solids. You can actually make negative shears, so where you have values coming back up and back down as well. So I hope you found this interesting. Just a quick tutorial on how to do shear, bend and solve reaction forces.